and the uncertainty therein, digital sequences, it tends to be interested in very wide bandwidth. Position and timing, on the other hand, even positioning is usually interested in timing, particularly as it relates to GPS. And that means that the signal is known. We know what the CDMA sequence is. The question is, what's the phase difference, or when did it actually start? Those two problems sound the same. They're quite different. And in solving them, and in sensitivities to interference, for example, in my opinion, they're quite different, and that brings us to a point that I'm going to make in just a second. The techniques, the use, I don't want to go into this, but you know there's lots of techniques for applications for COM, and many, many applications for positioning and timing, and I don't think we have to go into that. One thing I will note is there's apparently over 3.5 billion GPS receivers out there now, thanks in a large part to Irwin Jacobs and his fine efforts on building all that capability into a chip, which is absolutely astounding. For $1, they're getting about 1,000 times what we had to pay $300,000 for, incrementally, not including the development costs back in the beginning. So quite an amazing capability. I've gone through here and showed a bunch of applications for GPS or PNT. In red, I have signified all those that represent synergies between navigation and communication, and you notice they're all over the place. For example, every differential system requires a COM link to pass the corrections. Right away, you have synergy, and it goes on and on. In many cases, the information generated by PNT is useful, and in other cases, such as CDMA, as Irwin explained, all the data that is normally stripped by a standalone GPS receiver is instead stripped back at the base station, so the time to first fix is compressed to something that is very, very small compared to the alternative. These are some of the additional synergies. Cell phones and towers, he talked about synchronizing air traffic control, of course, automatic dependent surveillance, which is one of the major hallmarks, I guess, of what's going to come up with the next generation FAA. Do we call it next gen? I think we still call it next gen. I'm asking Karen Van Dyke, our senior DOT official here, keep me on the straight path. So the point is there's lots of uses. And there is another synergy, and apparently this is a little controversial, and I may be wrong about this, but I went in on the internet and I said, well, you've got 802.11 all over the place. Why can't you use that for positioning in some creative way? I am told that maybe you can, but the AC is not the right way to do it. Maybe you want to go to N or one of the others. But at any rate, the idea is very interesting. In many buildings, there are multiple nodes, all of which could be a ranging node. And is there some way to exploit that and give you meter level accuracy? And I think that's the issue. They have as a goal 1 meter, but I have to hasten to add, it's not yet proven apparently. And as near as I could tell, there is a group, IEEE or some such group, NGP study group, which is looking at this. Conflicts. Now I used the word scarce spectrum, and one of my Marconi colleagues said, well, it isn't really scarce. Well, it's scarce if someone owns a piece and wants to change it in a way that is destructive. There's certainly a problem of inadvertent interference, collateral damage, or passive nav. And I'm saying this from the standpoint of the PNT user. And so I want to simply talk about one example that is current choice and is keeping me up a lot at night. And that's this one. There is a band, 2 bands actually, very close to GPS. You can see the frequencies. The proposal is to convert it from a satellite to ground link to a high power terrestrial link. And Irwin, I would suggest your company should worry like heck about this. They're proposing 40,000 terrestrial transmitters. They're claiming that the latest proposal is different. It is not different. It is the same as it was to begin with. 5 years ago, we tested and found out that it is indeed destructive of many of the high-precision applications, which use the whole GPS band, the width, to get the sharpness and the timing. And as a result, you're looking at potentially destroying productivity in the United States, and I'm going to be very candid to give somebody a windfall profit of $10 billion. And frankly, that irritates me as a taxpayer. Just to give you the idea, the problem is these transmitters are going to be all over. UAVs, you're going to fly in the close signal pattern of those transmitters. If you think that's under control of the FAA, or you think it's under control of the operator of the UAV, he's going to lose control if he doesn't know where he is. So, very serious problem, and what we have said, because it's true, is that the signal power ratio at a quarter mile is 5 billion. And I like to show this chart to give you an idea of what 5 billion to 1 really looks like. The power of Niagara is roughly 1 billion watts. The power in a tablespoon of water dropped 5 feet once a second is 1 watt. That is 5 billion to 1. And frankly, that is a very hard problem if you want to have wide bandwidth in a GPS signal, if you want to use it. It may be solvable, but the trouble is the existing equipment that's controlling a lot of things has not solved that problem. So, the major questions, I'm about to introduce a panel, or I'm going to be leading a panel. What can cell phones do to cope with jamming? And we heard some suggestions already from Irwin. Can adjacent band terrestrial wideband communications, such as is advocated by the company called Legato, is that compatible with GPS, GNSS? Can it be made compatible? Will 5G or 802.11ac change the synergies between nav and comm? In other words, will this lead to actual indoor positioning, perhaps synchronized with GPS, perhaps not? I'm not going to system engineer it, but it sounds like an opportunity, but obviously there's a lot of challenges to do that. And will the near future advent of 4 major GNSSs modify our perception of either internet, cell phones, or any of the other synergies that we can see? So very rapidly, that was my 5-minute introduction, and now I will go to my room.